All right, now today we got Unit 7, Day 2. We've talked about exponential functions. If I can talk right. Now today we're going to graph them. So we're going to graph them, see what they look like. Every unit we do, we take a new kind of function, we learn what it is, and then we graph it, and then we try to figure out shortcuts about it to make things easier. So let's try to find some of those shortcuts on this one. So first off, look at this guy. We've got I got a t-table here, -3, -2, -1, and I've got y to the 2 raised to the, or y equals 2 to the x power. Again, that's an exponential. It's the exponential functions. That's when the variable is in the exponent. Okay, so it has to be in the exponent. Yeah, and I should do my learning target. I didn't say that. So I can sketch exponential growth and decay functions. Y equals ab to the x. I can identify domain, range, asymptotes, and intercepts. So hopefully, domain, range, and intercepts we've heard. I'm not sure we've talked about asymptotes yet. Yeah, but we'll talk about that in a bit. So first off, I'm going to pause the video. I want you to raise or plug it into this one. Just fill out this table right here. Keeping in mind that when you have a negative exponent, so if I have 2 to the -3, remember a negative exponent is actually going to flip it over, so it'll be 1 over 2 to the +3, and then that would equal 1 over 8. So if I took 2 to the -3 power, it's 1/8. Okay. I'd love for you to do it by hand. You can also type in the calculator if you want to, but fill out that first column. Okay, so you fill those out. Again, this would be 1 over 2 squared, which would be 1/4, and on down the line. So go ahead and plot these points. So at -3, I'm at 1/8, so I'm barely off the x-axis. At -2, I'm at 1/4, and not too far above. At -1, I'm at 1/2. At 0, I'm at 1, and then at 1, it's 2, and then at 2, it's at 4, and then at 3, it'd be pretty much off the chart here. So 1, 2, 3, 4. I'm going to estimate and put it somewhere over there. So it looks something like this. Now, one thing, will this ever cross down into the negatives? So will this cross the x-axis? And you think if I have a positive number and I'm multiplying it by itself any number of times, can it ever become negative? A positive times a positive, no matter how many times I do it, it's going to be positive. So this is going to follow along the x-axis. As I go to the left, it gets closer and closer, but it never actually touches it. It's going to come up along here like this, and then it really shoots off fast. It's still going to the right and up, but it takes a long time. So it's a smooth curve. I didn't draw it so well, but it's a smooth curve. And because this goes along that line and never really touches it, that's what an asymptote is. I'm going to draw a dotted line in here. You can barely see it, but I'm going to put a dotted line right there. An asymptote basically says, you get very close to this, but you never actually touch this line. So the graph comes down and goes along that line, and that asymptote line would be y equals 0. Okay, so that's our asymptote. The domain on this, and I'm going to do both of these. Maybe we should do this one now, and I'll graph it, because they have the same domain and the same range. They have the same intercept and the same asymptote. Okay, so these two just happen to have exactly the same. So I'm going to pause the video. I want you guys to fill this out now. Keep in mind, 1 over 2 to the -3 power. To make that a positive, I'd flip this over. This would be 2 to the 3rd power. If I flip it over, the exponent becomes positive. So that's going to be 8. So fill out the rest of that column. Okay, so you fill out that table, and if you look, basically it's just the same numbers in opposite order. So if you remember from yesterday, both of them have, if you think y equals a b to the x, well, the a on both of these is a 1, because this is 1 times 2 to the x, and this is 1 times 1/2 to the x. So the growth factor here is a 2, means you're doubling every time. So that's growth. It's going up, 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 up. This is a 1/2 growth factor, less than 1. That means it's decay. So this one's going to be going down to the right. So at -3, it's 8, so it's off the chart up here. At -2, it's at 4. At -1, it's at 2. And it kind of goes like this. It just keeps getting, but it gets closer and closer, but never touches that line, because again, I have a positive number that I'm multiplying by itself. It can't ever become 0 or become negative. Because if you have a number, if you have something, and you're multiplying it by itself, it's going to stay something. It never becomes 0, and it never becomes negative. So it falls along that asymptote there. So the domain on this one, if you look, goes left and right forever. So any number, I can plug anything in here. So the domain is negative infinity to infinity. Now the range, remember, is up and down. I have no graph down here. I have no graph right there. I start having a graph. So it starts at 0, but 0 is not included because 0 never comes out as an answer. You look in these, either one of these columns, you'll never have a 0 in there. And then it goes up to infinity. The intercepts, it never crosses the x-axis, but it does. So I'll say x-intercept, none. Y-intercept, in this case it's 1. And that's the A, the one that's in front. It's not really being written right now. So A is your y-intercept. And then the asymptote again on this one was y equals 0. Okay, so let's fill this guy out here. And if you put this in a calculator, make sure you put parentheses 3 and then parentheses 2 to the x power, or 2 to the negative 2, negative 1, and so on. I'm going to fill this table out. I should say in this first one, like when you have 2 to the negative 2 power, the 2 gets flipped over, so it'll be 1 over 2 squared, but the 3 doesn't. The 3 has no power on it, so I don't need to do anything with that yet. 1 over 2 squared is a fourth times 3 is 3/4. So fill that table out. Okay, so you get a table like this. Okay, now maybe pause the video and go ahead and plot those points. And when I plot them, it makes this kind of a curve here. Now keep in mind, it is going right and up forever. Now as I go to the left, what's it going to do? Well, as I put bigger negatives in, this is going to flip over. I'm going to have bigger numbers on bottom. So that 1/4 will become an 1/8, will become a 16th. So you have 3/8, 3/16. So this keeps getting smaller and smaller and smaller, but it will never become 0 and it'll never go negative. So it's going to go along that asymptote right there. So there's an asymptote going along here that blocks it from going any lower. Again, domain negative infinity to infinity, goes left forever, right forever. The range starts at 0 and goes up forever. Intercepts has a y-intercept. Now, look at this. It intercepts at 3. What number's out front right there? 3. That is your y-intercept. I could have told you that before we graphed it. And then the asymptote here is y equals 0. That line y equals 0 right there. Again, x-intercepts, there's none. Oh, maybe I should say this too. I should say 0, 3 is your intercept. I'll call that the y-intercept. So 0, 3 is your y-intercept. I think in Math Excel, if you say 1, it probably count wrong. If it's once an ordered pair, make sure you put 0, 1 or 0, 3. And this guy here, I can answer a few questions ahead of time. It's an exponential, so the domain will be negative infinity to infinity. All of them are. All of them they'll always be like that. Now the the range, it depends. Better graph it first because we can do some manipulations to it to change that. The intercept on this one, it's not going to have, well, it could have an x-intercept if it went down, if I shifted it down. But I can tell you right now what the y-intercept is. The y-intercept is at 4, so 0, 4. Okay, and this one, it has no number on the end of shifting up and down, so the asymptote will still be y equals 0, which means the range will be 0 to infinity. But maybe we'll deal with more of those later. We'll shift it up and down on you. But now let's fill this guy out, and then you can use your calculator if you want. Maybe I'll show you too. If you ever want to use a calculator to fill out a table fast, you go to y equals and put that in there, and then I want to see the table, so I'll go to second, and then table setup. I want to start at 0, and I want to go up by 1s. Now press second, and then table, and I can see my graph here. If I go up to -2, I can type these numbers in here. I'll put it over here. So 11, 11.1. That's 6 2/3. 4, 2.4, and 1.44. Something like that. These first two I could do in my head. This one I'm not going to be able to do 0.6 in my head, so I wouldn't necessarily expect you to do that. Now, if I want to plot these guys, well, if I go to -2, I'm off the chart. If I go to -1, that's 1, 2, 3, 4, 5, 6, and 2/3 somewhere in there. 0, 4, 1, and 2.4 somewhere in there, and then 2, 1.4. But it is going to curve, and notice this is 0.6 is less than 1, and this is decaying. As I go to the right, it's getting less and less and less, but you can never lose everything. If I'm multiplying a positive number times itself, it's going to continue to stay positive. So it's going to come down like this and follow that line. Okay? Look at the back side here. And I want to go a little bit shorter here. I want to go a little bit faster. I don't want to make a t-table every time. So I told you that this right here is your y-intercepts. Right off the bat, I could plot a point right here at 1/2. And then this is the growth factor, which means it's tripling every time. So if I'm at 0.5, for every time I go over, it's going to triple its previous value. So if it was at 0.5, triple that, that's 1.5. If I triple that, that's going to be 4.5. So I go over here, I got to go up to 4.5. If you triple that, 4.5 times 3, let's see. I'm going to use my calculator, I don't trust myself. 13.5, that's going to be off the chart. As I'm going to the left, well, it's going to be 1/3. So triple, if I'm going this way, if I'm going the other way, I got to do 1/3. Well, 1/3 of this, I can't even tell the difference. But I do know that I'm going to have something, so it's just going to keep going along that x-axis. So it's going to go like this, along there, and then it's going to shoot up pretty significantly fast that way. So domain, -infinity to infinity, range, in this case from 0 to infinity. Intercepts has a y-intercept, so the y-intercept, I'll just put an arrow, is going to be 0, 0.5. So 0.5, and then the asymptote is y equals 0. Maybe I'll just do one more of these. I think maybe you're getting the idea. You know, if this one I would start at 5, 1, 2, 3, 4, 5. I go about 7/10 of that previous amount. You can multiply by 0.7 and graph it this way, but in the end it's going to look something like this if I just sketching it. Just real quick sketch. -infinity to infinity, range is 0 to infinity. Basically all the same thing as this, except for that'd be at 0, 5 instead of 0.5. Number 3, they don't have the 1 there, but this y-intercept is 1 because it's y equals a b to the x. So if they just have b to the x, that means a is a 1. So you know that it's going to cross at 0, 1. This is 4/5. So if I go to the right, I'm going to do about 4/5 of the previous amount. Well, that's just going to get down to 0. If I go the other way, I'm going to do 5/4. So it's going to go up and up and up and up. You know, if I want to go the other way, if I want to find the previous amount, I could do, this is a 1. Instead of multiplying by 4/5, I'm going to divide by 4/5 if I'm going to the left. So divide by 4 divided by 5. So it'd be at 1.25. So it's not going up too fast. And then divide by 4 divided by 5. So 1.5. Actually pretty slow, but it is increasing, so it's going to look something like this. Now eventually it will shoot up. It's going to the left there. So, and then we'll just do this. So domain, -infinity to infinity, range, again 0 to infinity. There was no number on the end, no plus 2, -1 that shifted it up and down. Intercept on this one, there was a y-intercept at 0, and 1, 1. And then the asymptote, again, y equals 0. So hopefully that's enough. If we finish the rest of the page, that can get you. It would be good, but I don't think we need to do all that. Hopefully you understand. And if you don't, if you're in class right now, raise your hand. If you are at home when you show up to class, I want to see the rest of these. I don't get it. I'll definitely show them to you.